Today we are going to discuss Computer Fundamentals Hardware Part 2. Last time we discussed Part 1. Last time we ended by discussing storage device like hard disk drive and SSD, solid state device, and the principles on which they work. So today we are going to continue with the hardware, and so we will discuss North Bridge and South Bridge chips, which are important chips which are there on the motherboard. So we briefly discussed North Bridge and South Bridge last time. So what's the role of North Bridge chip? So the role of North Bridge chip is sorry. The role of North Bridge chip is sorry. So this is the North Bridge chip. So this is the location of North Bridge chip. This is CPU and the North Bridge chip is here. And then south of North Bridge chip is the South Bridge chip. So what does the North Bridge chip acts as a communication hub between the processor and other components of the computer system like memory, graphics card, high-speed graphics card. So this North Bridge chip is actually responsible for processing high-speed information. So this is the memory slot. Memory slot means primary memory slot, that is RAM, and this is the slot for high-speed graphics card. So it processes information from these two slots. So this is the CPU. So it's a controller hub. And then you have the South Bridge chip. So what does South Bridge chip do? So it handles input-output operations. So I and O means input-output operations like USB, storage, PCI, and systems firmware like BIOS. We'll come across these terms in the next slide. PCI we know, Principal Component Interface. We have done it in the last class, lecture. So this is BIOS, Basic Input-Output System. So this handles fast operations, and the South Bridge chip handles which are comparatively slower. So it handles slow operations like USB, storage, PCI. PCI is where the sound card may be there or Ethernet card may be there. So this is the graphics controller. This is PCI bus. This is input output. This is the super IO input output it controls. And this is the ROM. ROM also will come to know what is ROM. So ROM is BIOS, Basic Input Output System. And so now we come to what is ROM. ROM is also there on the motherboard. ROM is a kind of computer storage that is non-volatile. That means if you switch off the computer, the information remains in ROM and can be read only and not altered. This is not all. We'll see there are kinds of ROM. In general, the information cannot be easily altered, you can say. It contains programs that enables the computer to start up. So when you switch on the computer, ROM plays a very important role. It contains what is called the boot firmware, which is also called the BIOS, Basic Input Output System. So what does the BIOS do? It connects the operating system like you have Windows or you have Linux or Mac OS. Okay, so the operating system has to see the hardware. So the BIOS helps the operating system to connect to the hardware. ROM is there in many gadgets you can find ROM. ROM is there in video game consoles. So when you play video games, ROM is always there. So ROM plays a very important part when you switching on the system. So it connects the operating system to the hardware. Actually ROM can be, so this is a typical picture of a diagram of a ROM. So ROM can be, it is programmed in factory and cannot be further programmed. Okay, so one is that it comes like programmed and you cannot do anything, it cannot be altered. So this kind of ROM you can find in maybe video games console or in washing machines also you can find ROM. And then you have programmable ROMs. This ROM can be programmed by the user. So initially it will not be programmed, but you can program the ROM. So that is called PROM. And then you have EPROM. So this type of PROM, this is programmable ROM, it can be erased and programmed again. So your computer may contain EPROM. So you can erase whatever is there in the ROM, and then you can program it. So how do you erase? One way of erasing is by using ultraviolet rays. So whatever data is there, you can use ultraviolet radiation to erase it. So EPROM may be of the type UV EPROM. This is another kind of ROM which uses ultraviolet ray to erase whatever information is there in the ROM, and then if you want you can reprogram it. Another way of erasing data from ROM is using electrical pulses. So this is EEPROM. So these are the kinds of ROMs you can have. And next you go to optical drive. So optical drive, what is optical drive? You may have like run CD in a computer. So for that you need an optical drive. With optical drive you cannot run CD or DVD in a computer. So it is a hardware that uses laser to read or write data to optical discs like CD, DVD, Blu-rays. So these are the kinds of optical discs you have. CD is a kind of optical disc, DVD is a kind of optical disc, Blu-ray is a kind of optical disc. And in order to read them, what you need is a optical drive. So there is a hardware that helps in reading the CDs, DVDs and Blu-rays. So it uses laser. So how does it use? Why does it use laser? We will soon see. And what are optical discs? Optical discs are flat. They are not perfectly flat. We will see why it's like that. Circular media made of polycarbonate, plastic and a reflective layer to reflect of the laser beam from diode. Laser falling on it. So the diode laser should get reflected off that optical disc. So there is a reflective layer. So we have different kinds of optical discs we discussed just now. So we can have CD, we can have DVD, we can have Blu-ray, etc. And they use different wavelengths. Okay, why? We'll see. CD will be, to read CD you will need a particular kind of wavelength. To read DVD you will need a particular kind of wavelength, and to read Blu-ray you will need a particular kind of wavelength. So from here you can see Blu-ray itself tells you that in order to read Blu-ray discs you have to use blue light. And what do these what does the laser light do actually? It uses the light to extract information about the pits and lands. And what are the pits and lands in a optical disc? So this is an optical drive, and what you are having is an optical disc. You can see it's shining, it's reflective, and the laser light. So whenever the optical disc is running, it spins. Optical disc always spins when it's running, and the laser light falls on it and gets reflected, and from that reflection, from the analysis of that reflected light, we can make out the data that is stored in the disk. So how is it that? Actually, if you closely look at the disk, the disk is not flat, but it contains humps like this. So what you have is what they call it, that's what we say, you have pits and lands, or flat. So these are flats and these are pits. Okay, so it's like ups and downs are there. It looks smooth here, but it's not like that. This is where information is stored. So how is it stored actually? So actually these things are arranged in concentric circles like this. Okay, so it's like this. So this pits and lands, so all this is in a particular, this is along a particular circle, this is along a particular circle, so this is along a particular circle. Okay, so like this you have circles, okay, so which contain this pits and lands, and then you have this, from there you have this kind of we have this kind of radius. So you have this radial drawings. So actually information is stored in things like this. This information is stored in this. I have not drawn it properly, it's very rough. So information is stored in these areas. So what the laser light does is it tries to read the information in this area, and then information is coded in form of this pits and lands. So this contains information as well as the address of the sector. This is a sector, so address of the sector. So closer these circles are, if the circles, the closer the circles, then you can say that more information is stored in the disk. So this is what differentiates these your disks. CD, these circles are slightly widely apart. In DVD, these circles are more close, and in Blu-rays they are very close. So in Blu-ray, these concentric circles are very close. So you can see it's that here the typical distance between two circles is 1 micrometer. Okay, so in CD if it's micrometer, then in Blu-ray it will be even less. So Blu-ray contains more data. So since the circles are closer, then in Blu-ray you have to use blue light to find out the information, whereas what information is stored. Whereas for CD we generally use we use a reddish light. In DVD you have to use a higher a smaller wavelength. Okay, so it has to be smaller than red light, and for Blu-ray disc you have to use blue light in order to read the data that is stored on the Blu-ray disc. So this is the concept, and then we go to CMOS. CMOS is a chip. So CMOS is also a chip that is on the motherboard. So it is a chip that stores data that the computer needs before the operating system is loaded. So before the operating system loaded, the computer needs some information, and that information is stored in CMOS. So what are the kinds of information that is stored in the CMOS? It tells you the types of disk drives that are installed, like SSD or hard disk drive or whatever is flash drive. What are the disk drives that are there? All those informations are there in the CMOS. So those informations are required before the operating system is loaded. And another very important thing of CMOS is the computer has an internal clock. So this internal clock is there in the CMOS. So the current date and time is there in the CMOS. So the computer uses this clock to function. And then using CMOS, you can go to BIOS settings. And why do you go to BIOS settings? You can go to BIOS settings to disable or enable certain drives. If suppose you don't want to use any particular drive, or you don't want to use any particular drive, then you actually go to BIOS settings and there is option for it to disable it. So when the operating system is loaded, the operating system won't see the drive, and that's it. So that is the idea. So the BIOS settings are there in the CMOS, and CMOS is also the clock of the computer. Now the important concept of cache memory. So cache memory is what? So this is my CPU, and here you can see cache memory. This cache memory is actually located inside the CPU. Though it is shown to be located outside, it is actually inside CPU. Then you have primary memory, that is my RAM, and then you have secondary memory, which is the storage device. So how does the CPU work? In order for CPU to work, the CPU needs some data very frequently. So those data are stored in cache and primary memory. So we have already discussed primary memory, so we won't be discussing primary memory. So we will be discussing what is cache memory. Cache memory is it's basically SRAM. It's not dynamic RAM, it's static RAM. So cache memory it's very fast memory, so access data from the cache requires very less time, and it sits between the CPU and the RAM. So basically it's very close to the CPU, these cache memories. So these are circuits, and what is this function? Hold frequently requested data and instructions which are immediately transferred to the CPU when required. So whenever the CPU requires any data that the CPU requires very frequently, then those kind of data are stored in the cache memory, and from there those data are accessed, and that access time is very fast. To access data in RAM, it requires time, because RAM requires to be refreshed, so data transfer is slow, but in cache memory data transfer is very fast. But the downside is that you cannot store much in the cache memory, whereas in RAM you can store a lot of data. So this cache memory is typically of L1 level, that is level 1, L2 is level 2, and L3 is level 3, with L1 being the fastest. That is, you can access data from L1 really fast, and then L3 is being the slowest. So to access data from L3, you have to it takes more time for the CPU. So you can as well you can forecast that L1 can contain very less data, then comes L2 and then L3. L3 can of all these cache memories, L1, L2 and L3 can contain the maximum information. So how does it work? The CPU first looks for data in L1. If it doesn't find, then it goes to L2 and then it goes to L3. Okay. So inside the CPU, what do you have? You have core. A core is nothing, so you have many in a CPU. You can have many cores. Not core means a processor. So you can have 1, 2, 3, 4, 5, 6 like that. You can have many processors. So each core in the CPU has its own L1, has its own cache memory. L1 type cache memory level 1. While L2 may or may not be shared between different cores. So it can be that this L2 cache is shared between say 2 cores. But L1, each processor has its own L1. And L3 is always shared between various cores and is situated farthest from the cores. Okay. So L1 has the lowest storing capacity, followed by L2 and then L3. So this is the hierarchy. So now we go registers. So registers are again there in CPU. So what is a register? So we had discussed memory cells before, and registers are made up of memory cells. So memory cells are, when interconnected in a particular way, they form a register. Some of the registers are located in the CPU, which are important registers, are memory address registers. Memory address register. So what is this function? It is abbreviated as MAR. So this type of register contains the address of data that has to be accessed. So if you need to access a data, you have to first know the address. So that address is located in this memory address register. So the CPU has to first access this register to get the address. Then you have instruction register. This register stores the current instruction that is being executed by the CPU. So CPU is, say, executing some instruction. It could be from some program you have written, say, in C. So this instruction register stores the current instruction that is being executed by the CPU. And then you have program counter, which is also a kind of register. So this kind of register holds the address of the next instruction that is to be executed after the current instruction has been executed. So once the current instruction has been executed, next there will be another instruction. So what that instruction is, the address of that instruction is stored in the program counter. So the CPU will access this program counter and will go to that address and execute the next instruction. Then you have a general purpose register. This register is used for storing immediate results from computation, as well as it can store addresses also. It can store addresses. Okay, it can store addresses also. So it's a general purpose. It can store data from computation, and it can store addresses and other kinds of things. While an accumulator is also a register, which is located in the arithmetic logic unit of the CPU, ALU, arithmetic logic unit of the CPU, and this is dedicated to store results from arithmetic and logic operations. So this accumulator is only used to store data that has been processed in the ALU, and ALU means it does the arithmetic and logical calculations. So we'll stop here, and thank you.